Okay, we've got question 13 from our shadow paper, an integration result that we're trying to show. So let's take a good look first of all. So trying to show that this thing integrated is equal to this. Now, where do we want to start? Well, hopefully this sort of expression underneath the root has got you thinking that integration by substitution might be a good idea. So let's do that. Let's let's try u equals x squared plus 2, and let's keep track of what that's going to do on our on our left hand side. So that's 2 to 0, that's x, that's root, and that will now be root u dx. So the step that we're going to want to do next, always with a substitution, is we're going to want to be doing du dx, which is going to be equal to 2x. And let's do the approach where we get dx on its own. So there's a few different ways we can do this, but let's say 1 over 2x du is going to be equal to dx. And the idea is that we are going to replace that dx now with all of this stuff. So let's write that in and let's see what that does. So 2, 0, x. I think we can write this as a u to the half while we're there as well. So dx is now going to become 1 over 2x dx. And we notice that we can do some cancellation. Okay, so what should we do? We've got a u to the half, we've got a half there. I think we should jump ahead now and say that this is the same as a half. 2 to the 0, u to the half dx. So my limits, I've left those limits in blue there to just stress the fact that they're still... hang on a moment, I just spotted a mistake. So that's why we check our work as we go. That should be du, isn't it? Because what I'm looking for is I'm looking to see that everything is in terms of u. But my limits started off in terms of x. So they still need to be changed. So what I'm going to do is I'm just going to sort of write this over here to keep track of it. So these are x values. Yeah, these are x values. So this is an x equals, an x equals. I want these to be u values. So how do you get a u value from an x value? Well, you can use this one here. So 2 squared plus another 2 is going to give me a 6. And 0 squared plus a 2 is going to give me a 2. So I'm pretty much ready to do all of that now. So that's a half between 6 and 2 of u to the half with respect to u. Let's do our integration over here. This, I'd often do this sort of as a box, sort of my key working out that, you know, I'm always pretty much going to have to do those 2 steps. And then I've got some extra steps there as well. So let's do a half. Let's say now it's going to be u to the 3 over 2. So what's the reciprocal of 3 over 2? It's 2/3. So 2/3 u to the 3 over 2 between 6 and 2. And I think we're just integrating this and showing this result. Okay, so what else can we do? We can take that one out there. So we can take that one out, which will give me 2 over 6, or you could actually cancel those, couldn't you? So let's do a third. And let's put our brackets in there. So a third, this is going to be just a 6, isn't it? So that's going to be a 6 to the 3 over 2. And then this is going to be a 2 to the 3 over 2. So let's take a look at the show that for some clues. 6s and 2s. Okay, that's a pretty good sign. In fact, we're almost there, no? We've almost stumbled on the answer exactly as it's written. The third is there already. Why does it say 6 root 6 and 2 root 2? Well, let me just kind of show you over here. So if I said 6 to the 3 over 2, isn't that the same as a 6 times a 6 to the half? Yeah, that's the same result, isn't it? So 6 root 6, 2 root 2. So I think we can just say our final answer here. I think we can just say this is 1/3 6 root 6 minus 2 root 2, as they have required us to do. So a substitution question for that one.